There were a lot of emotions when I was laying on my deathbed, all 5 times. I'll never forget what it was like to have my dad, my sisters, my friends coming in to hug me and to say their final goodbyes. And my doctors were sure that this was it. And I remember my sister sitting next to me and saying, "Just breathe, Dave, just breathe." And I remember hearing that, and I said, "You know what, I can do one more breath." And amazingly, that's when that first set of chemotherapy kicked in. My name's David Fajgenbaum, and I'm a physician scientist at the University of Pennsylvania. I'm also a patient with Castleman disease. Castleman's is this horrible rare disease where basically your immune system attacks and shuts down your vital organs. And it's just relentless. It doesn't stop until it kills you or you use treatment to stop it. During the time when I was battling Castleman's and also in med school, it was just so tough because I was simultaneously receiving chemotherapy to try to keep my disease in remission. So I felt pretty horrible from the medicines I was taking. And then I was taking care of patients, and that's all I wanted to do. But I was also dealing with just fear of the unknown. I didn't know when it was going to come back, and it kept coming back. I nearly died 5 times in those 3 years. And so I had this clarity that, like, okay, if I want to survive, I've got to find a drug that can save my life. And I can't just sort of hope that some researcher somewhere is going to figure it out. I've got to turn my hope into action. So my mission became really clear, and that was figure out what's going wrong in my immune system, and then figure out, is there a drug that was made for another disease that can maybe fix the problem in me, in my disease? So I started performing experiments in a lab just down the street on my own blood samples. I discovered that a key part of the immune system called mTOR, it's basically a communication line for immune cells to talk to one another, was turned into overdrive. And maybe if I use an mTOR inhibitor, I could turn this off, and then maybe that would keep my disease in remission. And so I talked to one of my doctors about this idea, and he basically was like, "Look, we got no other options for you, so why don't we try an mTOR inhibitor?" And now I've got 10.5 years of remission while I'm on this drug. So rather than going on to do a medical residency, which was sort of always the plan, I went right to joining the faculty here at the University of Pennsylvania, where I could just dedicate 100% of my time to research. All I wanted to do is, after finding this drug that could save my life, is to get this drug and as many other drugs as I could to other people to save their lives. I joined together with my 2 co-founders, Grant Mitchell and Tracy Sikora. We launched EveryCure, and the premise of EveryCure and our mission and vision is to unlock the full potential of every FDA-approved drug to treat every disease in every patient that those FDA-approved drugs can possibly treat, not just the 1 or 2 diseases that those drugs were intended for. And so we've been talking about it, dreaming about it, but it really wasn't until the advent of next generation and more recent artificial intelligence technologies that have helped us to say, okay, we can scale what I do in my lab 1 disease at a time to look across every drug and every disease. One way to think about our AI platform is to think about the way that streaming services recommend different shows for you to watch. And the way that it does that is it uses something called a random forest algorithm. And the random forest algorithm will basically look at all the shows you've looked at in your past. And then it profiles all the shows out there that you haven't seen yet. And then it matches them together and gives you a score. We utilize an almost identical algorithm to make matches between drugs and diseases. So our algorithms characterize and come up with a profile for every drug and every disease, and then gives a score for how good of a match it is between that drug and that disease. Figuring out ways to leverage these incredible technologies so that way humans aren't spending days and days reviewing through every study when you could utilize generative AI to do that in a matter of seconds. I live with the belief that hope is really, really important, but hope is not enough. Hope has to inspire action. It's just been the honor of my lifetime to be able to work here at the University of Pennsylvania and through EveryCure to save lives with cures that are literally just sitting at the pharmacy shelf.